Okay, this is Temasek Secondary Pure Physics Prelim paper 2014. This is paper 2. So just to comment about this paper, compared to paper 1, I think paper 2 is relatively easier. So you should aim for at least 75% when you're attempting this paper. Okay, let's begin. Okay, question 1 is your kinematic. So when you are faced with this kind of question, don't panic. Okay, first identify whether this graph is a dt graph or is it a vt graph. So in this case, this is a vt graph, similar to your speed time graph. Now, take note in your part A. Part 1 is pretty straightforward. You need to deduce when the engine malfunction, and when this happens, basically your speed will not go up anymore. Okay, so part 1 is quite simple. Just find out what is the time when the speed no longer increase, and this is 18 seconds. Now part 2 is a bit tricky. Most of the students would think that this is 90 seconds, but actually when the rocket reaches the highest point, the velocity will become 0, right? Because that is when you start to change direction. At the highest point, it will change its motion to a downward motion. So what happens is that, let's go through the graph step by step so that everyone can follow. So at the beginning, at this point, the rocket is at the ground. So what happens is that your rocket is actually taking off. So this is when time is equals to 0. So what happens to the rocket is that as it goes up, velocity will continue building up because you have the rocket propulsion. So it will overcome the gravitational pull, and as it goes to t equals to 18, that is when the engine get cut off. Now, even when the engine get cut off, because it has a high velocity at this point of time, okay, it will still take some time for the gravity to pull it down. So at this point, at t equals to 18, the next moment is not that the rocket start to fall. Okay, it still have some upward inertia, and the rocket will continue to go up, okay, until the velocity becomes 0. That is when your rocket start to fall. So as the velocity goes to 0, this is the point. So that's why t equals to 50 is actually your maximum height. Then after that, gravity will start to pull it down. That's why the velocity is in the negative region. And you can see that the magnitude is becoming more and more negative, because as gravity starts pulling it down, the rocket basically accelerates towards the earth until it hits the ground. Okay, so be very careful with these 50 seconds. Okay, so at the maximum height, this is t equals to 50. Okay, part B and the next few part is quite standard. You are asked to find out the gravitational field strength. Now take note here, gravitational field strength is actually the same as your gravitational acceleration, just that they have different units. Okay, so since the value is the same, you can use the gradient to deduce the magnitude of this field strength. Okay, now the tricky thing is that if down here you write meter per second square, you won't be able to get the score, because down here the quantity required is field strength, and field strength will have the unit Newton per kg. Okay, so take note of this. The value will be the same as your gravitational acceleration, but the unit is different. The unit is Newton per kg. To find the weight is quite simple. It's just mg. The g will be the one that you find in B part 1. Part C is also quite simple. You have to find the inertial acceleration. That means at time 0, what is the acceleration? And during the initial takeoff, the acceleration is constant. So you just need to find the gradient of the first part of the graph. Now part 4 is a bit tricky. Most students got this wrong because they didn't take note, or they didn't take into consideration the weight, and they directly substitute m times this acceleration and think that that's the answer. Now when you are using F equals to ma, please take note that the F here refers to the net force, the summation of forces. So what happened is that before the engine malfunction, that means it is still functioning the moment, but the next moment is stopped. So at this point of time, there will always be a downward force, the weight acting on the rocket, and then the rocket will have a propulsion force of F. So the net force at this moment, okay, the net force actually consists of two parts: the upward acting force from the engine and the downward acting weight from the earth. So when you are using F equals to ma, please take note that this F net consists of two parts: the F engine minus of the weight, because these two are acting in opposite direction. Okay, so because of that, your ma, when you bring this weight to this side, it becomes plus. Okay, and the weight is 150 kg, so the mass is 150 kg, so when you convert it into weight, you must multiply by 10. Then after that, you can get the answer. Now, I just want to stretch some students further. I want you to think about the weight. Now, as the rocket propel itself up, will the weight be constant or will it change? Okay, so leave a comment, then we can discuss. If not, you can come to my office and we can talk about it. Okay? Okay, question 2. Question 2 is about moment, and it's about whether or not you know what is center of gravity. So part A, I'm not going to elaborate. If you do not know how to answer this, refer to your book. Okay, for part B, yes, you have to indicate the downward arrow and you have to label as what is required here, a capital W. Some of you go and write down F, some of you put a small w. All these will have mark deduction. Okay, the question requires you to label it as capital W. Now, another thing is that when you are drawing down the arrow, please at least have a little bit sense of scale and make sure that it is at the midpoint of the bar Q. Otherwise, it is even more advisable to identify, okay, what is the distance from one end of the rod. So here you indicated that it is 1.2 meter. There's no gray area. Okay. Okay, for part C, read the question carefully. It consists of two parts. First part, they ask you to predict, and second part, they ask you to explain in terms of moment. Okay, so my answer will have two parts as well. So first part, I am explaining how I come to my conclusion, which is here. So remember when you're talking about moment, you must identify where is your pivot. So in this case, I indicated that taking moment about point O. So here I will tell the reader where is my pivot. Then after that, identify the force that is causing the moment. So in this case, the force that is causing the moment is the weight, the W. And it will cause a net, what is the direction of this moment? So it's a net clockwise moment on Q. The body is Q. Yeah, so then after that, my explanation is over. I state what is my prediction. So as a result, Q will topple to the right. Some of you ask me, what if you didn't indicate that this is a net clockwise moment? Now, if you didn't indicate that this is a net clockwise moment, I think in this case, it is pretty straightforward because there is only a singular force. So if you didn't indicate that this is a net clockwise moment for this question, I don't think I will penalize you. But if there are more than one force acting on Q, okay, you need to identify that after you sum up all the moment caused by different individual forces, what is the net moment created? Okay, if not, you won't be able to conclude which direction is the Q going to topple to. Okay, that is if there are more than one forces acting on Q. So in this case, there's only a singular force. It's okay if you didn't write the word net, but it is a good practice to be precise, to be accurate. Okay, so for your part D is quite simple. They are asking you if I have a force acting on X, what would be the magnitude of this X. So just use your principle of moment. Clockwise moment equals to anti-clockwise moment. The only thing that you may find it, some of you may find it difficult is that you need to be able to identify what is the distance from the pivot O to the force W. But actually it is quite simple if you label all the distance. So 2.4 minus of 0.8 minus 4 1.2, you'll be able to find this distance here, which is 0.4. Okay, then after that do your algebra, you'll be able to get an answer. This W is given to you. So W is given, yeah, right here, 6 Newton. So just substitute 6 Newton here, you only have one unknown, you can find the answer. Okay, question 3 is about your energy. Okay, so part A basically is a giveaway. Just use P equals to mgh, you'll be able to find the answer. To find the gain in kinetic energy, it's quite straightforward also, just use half mv square. Be very careful of the square, you have to square it, okay, before you do the minus of. Down here what I did is that I basically, because this is half m and this is half m, so they are the common factor, that's why I take it out. Okay, I just did a factorization, that's all. To find the average forward thrust, you have to use conservation of energy. So what happened is that if you look at your part B and part A answer, you will see that at the end, the kinetic energy has actually a very large gain. It is even larger than the loss of PE. That means there is some additional energy going into the system down here. Okay, because in a normal case, the loss in PE will be equals to the gain in KE. So in this case, the gain is much larger, meaning that there must be some additional work from external sources that goes into this gain. So what happened is that there is actually a thrust from the engine. So meaning that this additional energy, okay, this additional energy 25000 minus of this 3700, the difference here must be coming from the engine. So use this equation. The additional energy must be equals to the work done supplied by the engine. So find the additional energy and equate it towards the work done. So notice here the engine must have a force that is acting forward, and because of that, the distance that you need to consider when you are calculating this work done must be parallel to this force, and that will be your hypotenuse length, which is your 28. So down here you get 28, do your algebra, you will be able to find the forces. Okay, assumption, no energy loss due to friction, sound, heat, and things like that. Okay, for part E, I actually got it wrong. I thought that they want the conservation of energy, the concept behind. But actually they want you to identify what is the energy that is being converted. So there are two parts to it. Of course, there is the change in potential energy, and then you have your thrust from your engine. But the thrust from or the work done from your engine actually come from the chemical potential energy that is being stored in the petrol. So indicate that these are the two energy sources, and they both are converted into the kinetic energy, and you will get the point. Question 4 is your kinetic model. So for part A, is quite straightforward. They ask you to explain what happened to what causes the expansion. So indicate that when the gas is pumped out, the pressure in the flask actually decreases. So first, identify what happened, what is the effect when the pump is switched on. Okay, then after that, relate this change in the environment to the phenomenon, which is the expansion of the balloon. So that's why you must indicate that after the M molecules are being removed, your pressure of the balloon will be larger than the pressure in the flask, and therefore your balloon expands. Okay, even though there is one mark, you must indicate what is the effect when the gas is switched on, okay, and what is the effect in terms of pressure to both your flask and pressure in order to get this one mark. Okay, for your part B, the question actually specified that you must use molecular terms, okay, to describe the pressure change inside the balloon. Okay, so before you attempt to use molecular terms to describe, you must be able to understand that the pressure in the balloon is not constant. Okay, when when the pump is switched on, the balloon will expand, so there will be an increase in volume, and when that happens, actually the pressure in the balloon will start decrease until the pressure of the balloon equals to the pressure of the flask. So once you have this understanding, now you need to put this understanding and describe it in terms of molecular terms. So first, indicate what is the change here. So when the balloon expands, volume increase. So have that context written down. Then after that, you can explain in molecular terms. So this volume increase, what is the effect on the molecules? So the average distance between molecules will increase. As a result. Okay, another way of saying this is that you can say that the number of molecules per volume will decrease. Okay, I would accept both. Then after that, go and indicate what is the effect of this increase in average distance. So the frequency of collision decreases, and that is because the volume of the space increased, but the average speed of molecule remain unchanged. Now this is very important. Okay, because you can assume that there's no change in temperature. Therefore, the molecules is actually moving at the same speed. Okay, so it is important for you to tell the marker that you know that the speed is not being affected. Or you can say that the average force exerted on the balloon wall by the molecules remain unchanged. Okay, you can identify either one. Either the speed is unchanged or the force acting on the balloon wall remains unchanged. Okay, that's because you are assuming that temperature remains constant. Then after that, finally, relate what you have described in molecular terms to the pressure. So since P equals to Fa, and the average force exerted on the wall remains unchanged, but A increases, so therefore your P would actually decrease. Now, at the end, you must also indicate, although just for completion's sake, okay, P would decrease until, okay, it is not decrease forever, it is until the pressure is the same as the external pressure. Then you will have a very, very complete answer. Okay, then now for part C. Part C, as long as you know that the volume is inversely proportional to pressure, you can apply this formula for your figure 4.1, and then you can find this constant here. Then after that, put this constant into the 4.2 context. Okay, down here, this is V, this is 1 over P, you get your pressure. Now take note, all your values given to you is actually in 2SF. So when you give the final answer, remember to round it off to 3SF or 2SF. Okay, this one may result in a deduction of mark. Okay, because you can't be sure until the fourth significant figure, since all your values given to you is in 2SF. Okay, question 5, I leave it blank so that I can show to you. So for part A, refer to your book. If not, you can just look at this image. Upright is dotted line, so it's virtual. Okay, and is the size bigger than the object? It is, so it's magnified. So it's quite straightforward. That's why I don't want to write it down. Then after that, you have to draw light rays, and then identify clearly the position of the lens L and its focal point F. So be very careful with the label here. You are supposed to label two things: the lens and the focal point with the respective short form. So how do you do it? Number one, this tip and the object must pass through the straight line. So once you draw this ray, basically you can already identify which is your optical center. Okay, and remember this part will be your virtual light ray, so dotted line here. So once you know that, you can already draw your lens. And after you draw a lens, okay, remember your lens symbol. Both the top and the bottom will have an arrow sign. Label it, okay, with a capital L. Then things become quite easy. You know that one ray will go straight, and because your image is formed here, meaning that all the ray will focus here. So what you do, you find this, and then you do it. this way. Okay, is that the end? No, you still have to draw the direction of the ray, and of course you must be able to identify that, okay, this is my focal point. Okay, once you have that, read what is the distance here and then write it down right here. Okay, state the change if the object is shifted 6 cm to the left. Okay, this one refer to your book. Okay, go to the page where they have all the different ray diagram for your converging lens. Okay, move your object appropriately. Take note that is the object distance more than 1f or 2f. Okay, if you are still having problem with part D, come and look for me in the office. I will try to guide you. Okay. Okay, question 6 is about your electrostatic. Part A is quite straightforward. It's a 1-mark question. You don't really need to explain a lot. But try not to write sentences like this, light charge repels. Okay, try to give a complete sentence, such as it is because blah 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 blah. Okay. Okay, for your part B, be very careful. Some of the students may think that this is an induced negative charge. Now, when the positive droplets approach the plant, yes, it will induce a negative charge to it. But if you read the context carefully, especially this line, the plant, which are reasonable conductor in this case, are in contact with the earth. So with this statement, it indicates to you that when the positive charge is brought near to the plant, what happens is that this plant is like a conductor, will start drawing electron from the earth and then bring it towards the region where the positive droplets are near. Okay, so as a whole, it will have an excess negative charge. Okay, that is different from induced negative charge. When you have induced negative charge, what happens is that, let's say you have a droplet here, positive droplet, and you have a plant. When you say induced negative charge, what happens is that you are saying that, oh, okay, my negative charge will be here, but at the same time there will be an equal number of positive charge on the left, on the other side. So overall, this leaf is neutral. Okay, this leaf is neutral, and that is what we meant by induced negative charge. Okay, induced negative charge here, this one. This is an induced negative charge. But in this case, because it is acting as a conductor and it is connected to the earth, what happens is that when you have a positive droplet here, okay, yes, it will still induce the thing, so there will be negative charge on one side, positive charge on one side. But the problem is, now the plant is connected to the earth. So when this happens, what happens is that the electron from the earth will actually be attracted by the positive charge here and then get attached to it. So what happens if you look at the plant itself, there will be an excess negative charge, right? So overall, this plant is already negative charge. It is not induced, it is negatively charged. Okay, so for your part B, you need to know that, okay, what is happening is the diagram on the right. It is connected to the earth. It is not just induced negative charge. So for part B, okay, start your answer with the context. So as unlike charge attracts the electron from the earth, remember this is electron, not proton or not positive charge. Not positive charge being running from the leaf to the earth. It is the electron, only electron can move. So electron from the earth actually flows to the plant when the positive charge droplet approach the plant. Okay, so that takes care of the first part of the context. So then after that, continue with, as a result, there will be more negative charge than the positive charge in the plant, making it negatively charged. Okay, so that's why you must conclude, okay, with the last statement, because the question is asking you how come it becomes negative charge. Okay, how come it becomes slightly charged? You have to indicate that the electron flows from Earth to plant, and as a result, there is more negative charge than positive charge in the plant. You need to have these two key points indicated in your answer. Okay, now part C is your general knowledge. So what happens is that if you have a smaller droplet, then the chance of it actually landing on your plant and not on the ground will be greater. Now it is not complete if you just mention that, oh, less chance of it will fall to the ground. You have to indicate in your answer that when your insecticide fall to the ground, it will cause pollution. So you have to indicate this negative effect in your answer, okay, for it to be complete. Okay, question 7 is, I love this question, especially the last part. It is quite, you have to think about it. It is not like, oh, okay, change to AC, then it will just alternate. Okay, oh, what is my paper? So ugly all of a sudden. Okay, for part A, for those who are still having problem, when you are trying to deduce that is your right hand grip rule. So look at, let's say this is the fixed soft iron. So what happens is that the wire will go on top of it, and the current is actually going up, right? So this is the wire that's going up. Put your index finger here, wrap around it, and you can see that, oh, north is on the left, which is your P. That's how you get your north pole. Okay, then after that, for B, you need to explain how can it move. So start the question with this context, because it says that when there's a current flowing through. So just say when there's a current flowing through, then a magnetic field is formed. Okay, you can add in another statement that the fixed soft iron, when this happens, the fixed soft iron will actually become an electromagnet. Okay, otherwise you can also continue with that the magnetic field produced by the coil will actually induce magnetism on the moving soft iron. Okay, and because unlike pole will attract, because if this is north, this is south, it will induce a north pole here, and the unlike pole will actually attract. The second key point you must indicate is that the force of attraction, okay, from the unlike poles will actually overcome this spring force. Okay, so you need to indicate that you know there is this spring force here, and this force of attraction must overcome this spring force in order for the needle to be moving. Okay, you need to indicate that. So then conclude. Hence the moving soft iron will start moving, and therefore your needle moves. State the function of the spring. As you can see, I also miss out a very key point, because I only say that, okay, the spring is to return the moving soft iron to the starting or the original position. Now the key thing is, when will it return the soft iron to its original position? So remember to indicate when. Okay, so this will only happen when there's no current, okay, flowing through the coil here. So remember to add in this statement. I personally feel that it is very important. Okay, without it, you may enter into the gray area. Okay, describe what you will observe if the direct current is replaced with an AC. Initially, I was thinking that the needle will start fluctuating from negative to positive, and it will not stay at a single point. But at deeper thought, if you look at this setup, when this is an alternating current, what happens is that, yes, the pole will start alternating. But because this is just a soft iron, meaning that that means this soft iron will react to the changing magnetic field, right? Okay, it won't interact. There is no fixed pole on this soft iron. So yes, when the alternating current is this way, so there will be north-south, then this will be north-south. So when it alternates, this will be south-north, this will also be south-north. So even though the alternating current is changing direction, there will always be a force of attraction. There will never be a repulsive force, because the soft iron is simply reacting to the magnetic field generated here. It's just a reaction. So no matter what, there will be still force of attraction. Now the thing about this is that yes, it will start attracted to this, and then this needle will point to a fixed value. But take note that when in reality your alternating current, let's say, is jumping from 0 to 10, and then from 10 it goes back to 0 and negative 10. Meaning that the magnitude of the current is actually changing. So there will still be some fluctuation in the needle. Because when your current change from positive 10 to 0 and then back to negative 10, your magnetic field will also change from very strong to almost nothing and back to very strong again. So there will be, although it is a force of attraction, the magnitude of this force of attraction will change. Okay, and because of there's a spring here, so your needle will definitely fluctuate. Okay, so with this understanding, you can now state it down step by step. Okay, so first indicate to the marker that you know that the needle will move to indicate the current's magnitude, but it will start fluctuating about that position at the same frequency as the AC. Okay, the needle, what will happen is that it will go to that place and then start fluctuating there. Okay, because your magnetic field is changing. Unlike in DC, your magnetic field is constant. When you use your AC, magnetic field is changing, so your needle will be fluctuating. Okay, then after that, explain to the examiner how do you come to this prediction. So say start off with AC would alternate the magnetic field of the coil. Okay, but however, this magnetic field will always induce an opposite magnetic pole on the moving soft iron, and as a result, there will always be a force of attraction. Okay, so this explains to the marker that, oh, okay, because there's always a force of attraction, so therefore the needle will go to indicate the current's magnitude. Then after that, you have to explain why the fluctuation. So continue. The needle fluctuates because the current changes from the positive maximum to 0 and to negative maximum and back. So just with a short explanation, you already have explained why the needle will be moving around. Okay, and that is because this is just 2 points. You do not want to spend too much time explaining in detail. But if this is a really a question with a lot of marks, then you may want to continue breaking down this explanation and says that, oh, okay, so when the current changes from positive max to 0 and to negative max, your magnetic field will also change that way, and therefore your force of attraction will also change from maximum to 0 to maximum and causes the needle to fluctuate. Okay.